Hi, my name is Tim Heden, and I'm currently a Ph.D. student majoring in exercise physiology in the Department of Nutrition and Exercise Physiology at the University of Missouri in Columbia. I am mentored by Dr. Joe Kanaley, and the overarching goal of our research is to examine how different lifestyle interventions impact metabolic health and metabolism in people. The purpose of this video is for me to describe some of the findings from my recently completed dissertation project. But before I talk directly about my project, I wanted to start with a little background information about diabetes and what diabetes is. So diabetes is a metabolic disease that results in abnormally high blood fat and sugar levels. So there are two types of diabetes. The first type is called type 1 diabetes, which affects approximately 5% of the people that have diabetes. And type 1 diabetes occurs because of a genetic defect in which these individuals do not produce enough insulin to control their blood sugar levels. The other main form of diabetes is called type 2 diabetes, which affects approximately 95% of people with diabetes. And type 2 diabetes occurs because the cells in the body stop responding appropriately to insulin. So next I'm going to discuss just some facts about diabetes. So diabetes affects over 25 million Americans, which is over 8% of the US population. If untreated, diabetes can cause kidney disease, heart disease, stroke, lower limb amputations, and blindness. Thus, it is important that diabetes is treated. Diabetes is the seventh leading cause of death. However, most people with diabetes do not die from diabetes itself. Instead, 2 out of 3 people with diabetes will die from heart disease or stroke. And one of the reasons why people with diabetes are such a high risk to develop heart disease is because abnormally high postmeal blood fat and sugar levels, which is common in people with diabetes, will damage the heart and cardiovascular system and contribute to the development of heart disease in people with diabetes. So given that abnormally high postmeal blood fat and sugar levels contribute to heart disease in people with diabetes, the main goal in the treatment of diabetes is to lower postmeal blood fat and sugar levels. Exercise can lower postmeal blood fat and sugar levels. We've known this for some time. However, the most effective time to exercise, either before or after a meal, is not known. I think it's important to establish the best time to exercise so that more effective exercise prescriptions can be made. So the research question that I had for my dissertation project was what exercise time, either before or after dinner, is more effective at lowering postmeal blood fat and sugar levels in patients with type 2 diabetes. So to answer this question, I designed a very simple study. The study design is illustrated right here in this picture. So my study consisted of 3 different trials. Each trial was performed in a random order, and every subject that participated in the study completed all 3 trials. So during each trial, the subject would come into the lab in the evening, and they would consume a dinner meal. And then before and after the dinner meal, I would take blood samples so that I can measure the subject's blood fat and sugar levels. The first trial that everyone did was called the no exercise trial, and that's illustrated here. And during that trial, the subjects would come into the lab, and they would not exercise and just be centered the whole time testing was going on in the lab. The second trial was called the pre-dinner exercise trial, and that's illustrated here. And during that trial, the subjects would perform 45 minutes of whole body resistance exercise beginning before dinner. And the third trial that everyone did was called the post-dinner exercise trial, and that's illustrated right here. And during that trial, the subjects in the study performed 45 minutes of whole body resistance exercise beginning 45 minutes after dinner. So next I'm going to discuss some of the findings from this study. So I had 13 subjects that completed this study, and this picture here is showing the glucose time course. Glucose is another word for blood sugar. So the blue line is showing the glucose time course, or the blood sugar time course, during the pre-dinner exercise trial. In between the 2 vertical blue lines here is the time frame when the subjects would exercise during that trial. The red line here is showing the blood glucose or blood sugar responses during the post-dinner exercise trial. And in between the 2 vertical red lines is the time frame when the subject would exercise during that trial. And the black line is showing the glucose response during the no exercise trial. So just looking at this figure alone, it looks like exercise lowers blood sugar levels. So one way that I can quantify a blood sugar or blood glucose response over time is by using a mathematical formula called the incremental area in the curve. So that's what this figure here is showing, the glucose incremental area in the curve. And the incremental area in the curve is just a mathematical formula that quantifies a response over time, and it makes it easy to compare a response between different interventions because it gives you just one number to compare. So in this picture here, the blue bar is showing the pre-dinner glucose incremental area in the curve, The red bar is showing the post-dinner glucose incremental in the curve during the post-dinner exercise trial, and the black bar is showing the glucose response during the no exercise trial. So the lower that these numbers are means the lower the glucose response was. So as you can see, exercising before dinner or exercising after dinner lowered the glucose response more so than no exercise. So the big take-home message from all this data is that independent of timing, resistance exercise reduces post-dinner glucose concentrations in people with type 2 diabetes. So next I'm going to discuss some of the findings for the blood fat from this study. So the blood fat that we measured was called triglyceride. So this picture here is showing the triglyceride time course. The color scheme is the same as the previous figure, but just to remind you, the blue line is showing the triglyceride time course during the pre-dinner exercise trial. The red line is showing the triglyceride response during the post-dinner exercise trial, and the black line is showing the triglyceride response during the no exercise trial. So I also used the incremental in the curve to quantify the post-meal triglyceride response. And again, the blue bar is the triglyceride response during the pre-dinner exercise trial. The red bar here is the triglyceride response during the post-dinner exercise trial, and the black bar is the triglyceride response during the no exercise trial. So as you can see from this figure, only exercising after dinner lowered the triglyceride response, whereas exercising before dinner, here in the blue bar, really had no effect. So the big take-home message from all this is that post-dinner resistance exercise abolishes the rise in triglyceride levels in patients with type 2 diabetes. So given that both triglycerides and blood sugar were lower with post-dinner exercise, the big take-home message from my study is that resistance exercise after a meal may be the most effective time to exercise to reduce the risk of cardiovascular disease in patients with type 2 diabetes. Thank you for watching my video.